Okay, so now we're going to be doing a couple of separable differential equation examples. Now, we have four given over here. Number one, we have dy equals to dy dx equals to x squared y. Now, luckily, this one we can easily separate these two. So as such, I'm going to move y to the other side, and I'm going to move dx to the other side, giving us dy divided by y equals to x squared dx. We then integrate both sides, and we're going to get that the natural log of y is equal to 1/3 x cubed plus c. Now, luckily for us, we can actually simplify y so that we have the following. Assuming that y is greater than 0, then we have ln of y equal to 1/3 x cubed plus c. Now, this condition, why I can assume it's greater than 0, is if we imagine that this is some kind of physical system, then this physical system would switch on at time t greater than or equal to 0. So as such, this thing may be strictly positive. Here, to get rid of ln, we take the exponential to both sides. Now, this right here, we can separate into two parts, e to the c and e to the 1/3 x cubed. Now, the meaning of e of e to the c is kind of, you can think of it like this. It's like a constant raised to a constant. That's still a constant. So as such, we can just represent it like so. C e to the x cubed divided by 3. Or if you want to, c exp of x cubed divided by 3. So that's the result for our first one. Now, the next one, we have dy dx is equal to 4x minus 1 y plus 1. Okay, similar to the first problem, we're able to separate the part containing y and the part containing x. So as such, we have dy divided by y plus 1 equals to 4x minus 1 dx. Similarly, we integrate both sides again. We get natural log of y plus 1 equals to 4. And this one right here, what ends up happening is this becomes x minus 1 squared divided by 2 plus c. Assuming that this whole part is greater than 0 again, we can do y plus 1 is equal to e to the c e to the 2x minus 1 squared. And as such, we have y is equal to c e to the 2x minus 1 squared minus 1. Third problem. Suppose we're given something of this form. Now, we have dy dx equals to 4x cubed e to the y. I mean, there's no difference for if the y is in an exponential or in a variable form. So as such, we're able to separate these once again. Divided by e to the y equals to 4x cubed dx. We then integrate both sides. Now, this right here gives us negative e to the y, or e to the negative y, when we integrate it. And this one gives us x to the 4 plus c. In order to convert this to an exponential form, or in order to convert this to a form equal to y, because we are able to do so, we multiply negative to both sides. E to the negative y is equal to negative x to the 4th plus c. We still keep it as plus c, mainly because a negative is still a constant. If we multiply that to a constant, it's still a constant. So as such, we always keep it plus c. Then we have 1 over e to the y equals to x to the 4 plus c. We then flip it. We have e to the y equals to 1 over x to the negative x to the 4 plus c. Take the natural log to both sides. We have y equals natural log. And we're going to keep it absolute just in case. 1 over negative x to the 4 plus c. And that is our result for this. Then for the last problem, we have the following. dy dx equals to 7 e to the x plus y. Using the property of exponentials, we can break this apart. E to the x, e to the y. And then we can start separating. We have dy e to the y equals to 7 e to the x dx. Integrate both sides. We have negative e to the negative y equals to 7 e to the x plus c. Similarly, we have 1 over e to the y, or 1 over negative 1 over e to the y, 7 e to the x plus c. Transfer the negative to the other side, we get 1 over e to the y equals to negative 7 e to the x plus c. Flip it, and we get e to the y equals to negative 1 over, it's supposed to be down here, 7e to the x plus c. Take the natural log to both sides. We get y is equal to ln of 1 over negative 7e to the x plus c. So far, all these problems are very straightforward. As long as we know our integral properties and our integral results, we're able to then compute the separable differential equations very easily. Now, suppose we're maybe given a situation where our result is ln of y plus e to the x squared y plus cosine of y. And this one's equal to maybe, tangent of x plus c. In this situation, we can't separate it. So we just circle it and we call it a day. Okay, thank you.